All right, welcome to Unit 7. Unit 7 is one of my very favorite units that we get to learn in 5th grade. It is all about operations and algebraic thinking. So we get to learn about algebra and the coordinate plane and order of operations. It really is one of my favorite things we do. So get excited for Unit 7. It is not a very long unit, so you'll find that as we get going through this, we'll have a test fairly quickly. The colors you'll need today are brown and red violet. You'll need to write the journal how it looks and then push play on the video. Let me kind of, before you do that, show you how big the chart is. So I went from one red line of my journal to the other light red or the pink line after I wrote the definition. And it goes pretty far down my journal, almost to the very bottom, but I left about 3 lines at the bottom. So make sure you leave some space at the bottom because we're going to be writing something at the bottom of that. So again, you're needing brown and this red violet, and you're going to make that chart pretty far from one red line to the other light red line, and outline it in brown and go pretty far to the bottom. So push pause on your video until you get it set up like this. Okay, so as you have written, an expression is a mathematical problem that does not have an equal sign. So it's kind of like giving information without telling you equals, but you still have to know that you're trying to solve that problem, okay? So we're going to give some examples of what is an expression and how do you write that in words, okay? We may not even have to solve them today. I think we will a few, but for the most part, we're just understanding what is an expression and how do you represent that computation in words. So the first one we're going to try is this. That is the expression. It does not have an equal sign. I just want to know what this means in words. So a lot of times people will say, oh, it's just 1/2 plus 2/3. That is what's happening, but there are different ways to represent how we say that, okay, what this means in words. So will you take your red violet and circle the operation? Operation means, is it add, subtract, multiply, or divide? It is addition. So we know that we are adding things together, right? So one way we could say this is add 1/2 and 2/3 together. Let's write that as one way we could write this. That is one representation of what this means. Add 1/2 and 2/3 together. And you know that we could reverse that and say add 2/3 and 1/2 together. That would work as well. But another thing we could say is using some more mathematical terms. What is a mathematical term or word you think of when you see the plus sign? Think about that for a minute. We know the word add. You might have heard the word plus when you were younger. But I'm looking for the answer to an addition problem. What are they asking me to find when they give this expression? They're asking me to find the sum. Okay? So what I could say for this expression is find the sum of 1/2 and 2/3. Right? Let's just write the sum of 1/2 and 2/3. And let's go ahead and break that into being done with that expression. So we draw a line all the way across. I'm going to circle the word sum because of the operation that we saw, and I'm also going to circle the word add in that first sentence. So this expression is 1/2 plus 2/3, but it is represented as add 1/2 and 2/3 together, or the sum of 1/2 and 2/3. Okay? Make sense so far? Shouldn't be too hard. Let's use our brown to lightly color the box at the top. This is the expression. Ready for the next one? Here it is. I know it seems so simple, but that really is what we're doing. Okay, you might have said in your head 10 minus 2. I want us to get a little more mathematical than that. What is really happening here other than minus? The word subtraction is happening, right? So we are subtracting, and then some people say 10 minus 2. No, if you put the word subtract, it means you have to start with the end number. So you would say subtract 2, and you can't say and. You have to say what you're taking it from. So you would say subtract 2 from 10. That is really, really a good way to say that. You could also say 2 less than 10. Interesting way to do that, right? Or you could do 2 less than 10. Those are both good examples of how to do this. I don't want you to say 10 minus 2. I want you to find new ways to say this. Probably the best one is subtract 2 from 10. So let's draw a brown line to separate that out. And then pick up the red violet. And why don't we circle the operation in this expression? The operation is subtraction, so I should circle that. And then I'm going to go over to my computation in words and circle the words that resonate or mean subtraction. If you ever say subtract, you should say from. And then the word less is also a subtraction word. Pretty interesting. I love this stuff. The next one, see, we're not even having to solve them. We're just evaluating the expression. We're saying, what does this expression actually mean? Ready for the next one? It is 1/2 times m. That's right, the letter m. So I can say multiply m by 1/2. Notice that when I put the verb first, like subtract is the verb, I started with the end. Multiply m by 1/2. Multiply m by 1/2. Because the operation is what? Multiplication. So I circle multiplication. I'm going to circle multiply. And the word by is another multiplication word. Something else I can say is 1/2 of m. Right? And the word of is the key word there. Remember, we know that multiplication means of, so we circle of. There's even another way that I want to represent this. That other way is find the, we'll just say the product of 1/2 and m. That's another way to say it. The product means the multiplication. So we have lots of different ways to represent this type of expression. Draw the brown line, and let's move on to another one. It's going to get more complicated, so if you feel like it's getting a little harder, it is. The next one we're going to try is this. I know you want to say 14 divided by 4. Well, that's how we read it, but what does the computation mean? What am I actually doing? Let's go ahead and say divide 14 by 4. The word divide shows I know it's division, and I'm dividing by something or groups of something. 14 divided by 4. Remember that this means it would be in the division house. It would look like that, right? So divide 14 by 4. You could say put 14 into groups of 4. Yeah? That would be another way to say it. The word put and groups might be examples there. Another one, let's put the quotient in there. So the quotient of 14 divided by 4. It's another one. What's the key word in that those words is quotient. Draw the brown line. Let's continue. Ready for the next one? You'll see that it gets much more complicated. Here we go. Wow. This problem really requires you to know something called the order of operations. So I'm going to flip my chart before I do anything, and I'm going to write off to the side here, order of operations. You have to know what things come first in order to understand this. So you probably learned this in 4th grade, but it's good for us to review it. It's called PEMDAS. Do you remember that? And write this off to the side. Maybe you didn't ever refer to it as that, but it's please excuse my dear Aunt Sally. That's something that I learned growing up, and maybe your parents have learned that as well. But what it means is each one of these things stands for a mathematical situation. And it's the order of operations, or the way we do mathematical things in a specific order. For example, it's kind of like, if you've ever played cards before, it's like having a trump color or a color that means more than the other ones. So for example, if I'm looking at a problem and it has parentheses, that is first, no matter what. We've talked about what parentheses mean. So parentheses mean I start with the parentheses. Okay? So the order of operations is you work in a certain order. You look for parentheses. If there's parentheses, you do that operation first. And then you multiply and divide from left to right, and then add and subtract from left to right. So multiply and divide go together. Add and subtract go together. Left to right. What that means is that there's both of those, multiplication and division, then you work left to right. And then if there's both add and subtract, you work from left to right. Okay? So let's go ahead and search for this. Are there parentheses in this problem? Yeah, so that is where you have to start. Okay, we have to start there. So in this situation, we have to find the sum of these, right? So you would say the sum of 3/4 and 5/8. The sum of 3/4 and 5/8. What am I going to do with that sum once I get it? I'm going to do 2.5 minus whatever that was, right? Well, there's a better way with words to say that. So what I do is I say the sum of 3/4 and 5/8 subtracted from 2.5. Right? Because we use that word from, we're working kind of backwards. So you have sum of 3/4 and 5/8 subtracted from 2.5. You can also say subtract the sum of 3/4 and 5/8 from 2.5. So you could say subtract the sum of this from that. All right, that one was definitely more complicated. Let's try the last one. Here it is. That's it. That is what it is. So if I'm using, this is the same thing, I have to use the order of operations in this problem as well. If I'm using the order of operations, does addition come first or does multiplication come first? Look over there at the PEMDAS and decide what comes first, addition or multiplication. Add is down here and multiply is above it. So multiplication comes first. Okay, this is what I have to do first. So I can say the product, because I know it's multiplication, the product of 6 and 1/10, or 0.1, added to 4.5. How did I know it was product? Because of that X right there, and that had to happen first. The product of 6 and 0.1 added to 4.5. Or I could say add the product, so I could start with this end part, add the product of 6 and 0.1 to 4.5. That might be a good way to say that. Pretty interesting way to say that. Add the product of 6 and 0.1 to 4.5. It tells me that I first need to find the product and then I do the adding to it. It's pretty interesting. And I know the words product of are meaning that multiply. But then I also have this addition symbol. And so I have to go through and figure out what words meant addition. I have added. I have the word add here, and product of again. It was just said a little bit differently. So did it get a little more complicated? Absolutely. But you can do this, especially as you work through what is happening in each problem. So instead of solving every single one, we're just trying to understand the expressions. And there are more than one way to write these things, so I don't want you to panic about it. I would like us to practice some though together. So what we're going to do is we want to write something about the order of operations at the bottom here so that we know that if it has more than one operation, we have to follow the order of operations. So we're just going to say with the star, if an expression has more than one operation, we must follow the order of operations. Go ahead and close that with the star. I'm going to make those stars this color. And I'm noticing on my chart that I didn't mark the on the 14 divided by 4. I didn't mark the operation, so I'm going to go back with my red violet and circle the division symbol. And then I'm going to turn the page of my journal, and I'm also going to get my workbook out, and I'm going to find page 283. It has a 2 count at the top. It says Unit 7, Lesson 1, and again, it's page 283. Push pause on your journal until you get those things. I'm going to get my name on this side. And I'm going to have my journal out and ready, but we're going to just practice a few before we go back over the order of operations, okay? So this says below are some expressions. An expression does not have an equal sign. We know that there's different numbers and symbols to express computations. So here's what they did. Add 3.5 and 6.3. Subtract 2 from 10. Multiply p by 1/2. Divide 14 by 4. Okay? There is more than one way to say some of the computations. So what is another way to say this one, the 1/2 times p? They did multiply p by 1/2. Remember in our journal we said, well, you could say 1/2 of p. Or I could say multiply 1/2 by p. There's lots of different ways. Okay, let's try number 2. Write the computation in words. Remember, if it's subtracting, you begin with the word subtract, and then you say the second number, the word from, and then write the first number. So it should say, subtract 2.25 from 7.5. Number 3 is really easy. You could say add b and 9. The fourth one, ooh, I've got some multiplication, both sets of multiplication. So remember, in this situation, I just am going to work left to right. So I could say multiply, because they're both multiply the product of 3/4 and 8 by 1/2. I'm using the product because I know it's multiply. So I'm saying I'm going to take the answer to that and multiply it by 1/2 because I worked left to right when it's multiplication. So multiply the product of 3/4 and 8 by 1/2. Number 5, let's look at their example. They just took and said the word divide, and then they went left to right. So let's just do the same thing. Divide 1.6 by 0.2. So again, I can just start with the word divide. Divide 1.6 by 0.2. Okay, now we're going to work the opposite, and they're going to tell us words, and we write the expression. Pretty cool. So find the product of 12 and 0.1. Take your red violet and circle the word product. Find the product of 12 and 0.1. Know it's product. So therefore I know it has to be multiplication. I'm going to use my red violet for that. Could it be written as 0.1 times 12? Yeah, but I'm just going to do one method because there's lots of different ways to do this. Number 7, subtract 2/3 from 3.5. Ooh, this one matters. You have to put the right number first. Remember, subtract 2/3 from means turn around. So I go subtract 2/3, but then the from means you have to put that number first. So it looks like that. I'm going to do the arrow for from. Pretty cool. And number 8, add 14 and t. Pretty easy. Number 9, divide p by q. Look at the example if you're struggling, like up in the chart. They did divide 14 by 4, and it was set up just like this. So let's put the first number first, the second number second. divide P by Q. Pretty awesome. Isn't this so fun? I think it's so awesome. Okay, turn the page to 284 because it's going to get way more complicated. It really is. So here's what we want to do, okay? I do want to get quite a bit of this information in our journal. So I'm going to try to cut out all of this. And when you come back to the next journal video, what I want to have done is I want you to have cut out most of this. So you're going to stay on the left-hand side where it says expressions with more than one operation. You're going to go all the way down. Get 10, 11, 12, 13, 14, 15, 16, 17, and cut off after that blue line. And then make it really, really narrow. Keep the chart, the order of operations chart. You don't have to keep the vocabulary. So it's going to kind of look like a Utah shape, I think. Anyway, I'll catch you in the next video and let's see if your shape and my shape looks the same.